Hi everyone, we are continuing our micro lectures on the time value of money, and today we are going to look at compounding a single sum when we have multiple compounding periods. So let's look at the formula. It's going to be slightly different than the formula we used for compounding when we have only when we're doing it yearly, so we have only one compounding period. The formula is going to be the future value equals present value times 1 plus r over m to the n times m power. So let's look at these variables. Future value is FV, present value is PV, the interest rate is denoted by R, the number of years is denoted by a lowercase n, sometimes it's an uppercase n, and then m is the number of periods per year. And it's putting that m in the equation, that's what differs it from using just one compounding period in a year. So we know when we have monthly compounding, that'll be 12, quarterly compounding will be 4, daily compounding will be 365. Sometimes for daily compounding, we have 360. That's a bank convention. So a lot of times in credit calculations, we'll see 360 as the number of days in the year. And then the right side of this equation here, this 1 plus r over m to the n times n power, that's our compounding factor. And I like to work with factors, so I always do this part of the equation first. So let's go through an example. We're going to assume that we have a $20,000 investment. The interest rate or the rate of return is 8%. We have monthly compounding, so that's going to be 12 compounding periods in the year. And then we're going to calculate that over 5 years. So when we put those variables into the equation that we saw earlier, we just have 20,000 times 1 plus 0.08 over 12, and then 5 times 12 is our exponent. So we just work that out, and we end up with a compounding factor here of 1.4928. And we multiply that by 20,000, and we end up with 29,856. That is the future value of $20,000 invested at 8% yearly, monthly compounding over 5 years. Now let's look at that previous example, and let's see what happens when we have different compounding periods for the year. So we change that m value. When we have one compounding period per year, the value is 29,386. When we have 4 compounding periods per year, we end up with 29,718. When we have 12 compounding periods per year, we have 29,796. And then when we have 365, so when we do daily compounding, we have 29,835. So what we see here is that the value is going up slightly when we have more compounding periods. So that's going to be the conclusion from the exercise that we did. The higher number of compounding periods in a year, the higher the investment growth. Thanks for watching, everyone. We hope that you like and subscribe our videos. We'll continue to make these, and we'll see you on the next one.